Hello everybody, this is Mr. Basil, and let's get to it. These are your video notes on Learning Target 5.5, which is all about predicting products for different chemical reactions. So the essential question for this video is right here. How can you predict the products of different reactions based on the type of reaction? So if you do not understand the 5 different types of chemical reactions, you need to go back and watch the optional video that's listed. Well, optional or not. It's the approaching level video for this learning target. So again, if you don't understand that, go back, watch the approaching level video, and that will be that. So again, you should be able to identify if something is single replacement, double replacement, combustion, synthesis, and decomposition in order to do this. So what I have here are 5 different types of reactions, and I'm only given the reactants. Based off of what the reactants are, you should be able to predict what the product is, because the reactants are all you really need to see in order to do this. In order to predict or identify what type of reaction this is. So the first thing you should do is decide what kind of reaction is this. So this one is a... Go ahead, pause it. Go ahead, pause it, and see if you can do this on your own. But I'm just going to go over and explain these now. So this is a synthesis. Synthesis. This is a double replacement. Synthesis because it's 2 single things, and you know that they have to come together to make something new. This is a double replacement because this magnesium and barium, they're going to swap places. And then this one, this is only one thing by itself, so it has to break apart into 2 smaller things. This is decomposition. This one is combustion. Now be careful for this one. It has to be combustion because we see O2 as the reactant. It's not single replacement. This one is single replacement down here, this last one. When the lithium and aluminum are going to swap places. The reason why this one is not single replacement is because it's a carbon, hydrogen, and oxygen. And the oxygen is a gas by itself. And so that's how you know that that's actually going to be an explosion or a fire or something like that. Okay? So, combustion. And then this one would be the single replacement. Alright? Now, the ones that are the most straightforward are the ones that aren't going to come up as often. So we'll start with those first. So if you have a synthesis reaction, all you're going to do is just put the chemicals together. So in this case, it's just going to be Na and Cl. Okay? And then one thing you have to be careful of is this is an ionic compound, so we have to make sure that the charges are neutral. So Na is a +1, chlorine is a -1. We just keep it as NaCl for this one. But, you know, if you put a 2 there, put a 2 there, and so on. The other one that's fairly easy is the decomposition. It's just one thing that becomes 2 things. So that's just going to become N and H. So that's all you got to do for that one. Combustion, the reactants are always CO2 and H2O. Always. So if you know it's combustion, you know what the products are, because it's always CO2 and H2O. Always is this for combustion. Alright, so let's spend some time talking more about the double replacement and single replacement, because those are the ones that you're going to see the most often. Alright, so here I just zoomed in on the single replacement and the double replacement. So when using replacement reactions, keep in mind that things are just going to replace other things, but you have to keep in mind that these are always going to have ionic, so for replacements, that's what these are. They're always ionic compounds. So make sure the formulas are cation, then anion. Okay, so it should always be positive then negative in your formulas, and the charges are balanced. Okay, so what do I mean by this? Well, for lithium and aluminum oxide, these two are going to be the things that switch places. And the reason why is in the end, you want to have aluminum by itself plus lithium oxide, okay? Lithium's a metal, oxygen's a non-metal. Remember, it has to be a metal and a non-metal, a positive and a negative, not the other way around. It would not be right, so if I ended up with O plus Li and Al, this would not be right, okay? This would not be right, because lithium is a metal, or it's a cation, and aluminum is also that. So it cannot be that way. You have to make a valid actual chemical formula here. So just be mindful of that. And then don't forget that you need to make sure the charges are equal. So it'd be Li2O, because oxygen would be a -2, Li is a +1. So that's why you end up with that there. Okay? Then this guy down here, go ahead and pause and predict which of the things are going to actually be doing the replacing. Is magnesium and barium going to be swapping places, or is it going to be the chlorine, or is it going to be, are the magnesium and sulfate? Are those two going to switch places? Pause and see if you can figure that out, and then I'll show you the answer here in just a moment. So hopefully you picked magnesium and barium are going to swap places. Another way to think about it is the chlorine and sulfate. Those are also, you could also think about those are switching places. The cations are switching and the anions are switching. Whatever the way you look at it, that's fine. But in the end, you should end up with the following: MgSO4 and BaCl. Okay, and you could have BaCl first, or or second, like I have it. Either way, it's fine. And it has to be this way because metal, metal, non-metal, non-metal. Okay, or cation, anion, cation, anion. And that's good. Now we just have to double check to make sure the charges are good, and then we're done. So Ba is a 2+, chlorine is a -1, so the chlorine would become a subscript of a 2, and then magnesium sulfate I think is good as is. Yes, this one's a -2, this one's a +2, so then it'd just be magnesium sulfate like that. All right, there you go. That's what I got, and thanks for watching, and see you next time.